So today we're looking at Chapter 20, the universe, but now we're looking at Lesson 2. What do we know about stars? Well, first of all, what is a star? Well, a star is a huge, hot, glowing ball of gas. Okay, when we look out into the sky, we see the stars, and they're twinkling. Well, this twinkling tells us a little bit about what is happening inside a star. So when we have a star, what we have is a lot of hydrogen atoms moving around. Now, each of these hydrogen atoms contains a nucleus. And we remember from Chapter 12, our weather unit, that when particles are really hot, they start to move around a lot. Well, when it's the temperature and the pressure from these particles is so high that they start bumping into each other at incredible speeds, so fast that they are able to collide, and when they collide, the atoms in the nucleuses, or nuclei, more than one nucleus, the nuclei fuse, okay? And this is called nuclear fusion, what's happening inside a star. And this nuclear fusion happens, okay? And what happens as a result is these two hydrogen atoms that are fused, okay, their nucleus are fused, their nuclei, they form a helium atom, okay, a larger atom. And so it goes from hydrogen and then it fuses to helium. And when that fusion is happening, a great amount of energy is released. This is what happens in nuclear energy, if you remember back to Chapter 10, or was it 11, the resources. So we have a lot of energy, and this energy is sent out in forms of radiation. Now, some of this radiation is going to produce the light that we see, okay? Now, also some small particles are also a result of this, so some extra particles are released as well. So we have the helium, the energy, and the small particles released from nuclear fusion. Now, if you remember looking at the solar system, we had large distances, right, between the planets. Well, if you think about it, from one star to the next star, the distances are even greater, okay? The space is enormous. So even astronomical units, or AUs, are too small to measure the distances in space. So scientists use something called a light year. You may have heard this term before, but do we know what it means? Well, the definition of a light year is the distance light travels in a year. So the amount of space that light will travel, okay, the distance. And are you ready for this? It is 9,460 billion kilometers. And that is very, very far. So, as a matter of fact, the speed of light, it could travel around the Earth 7 times in 1 second. So just imagine that in terms of 1 year, 9,460 billion kilometers. And so what that means is that, or not what that means, the next closest star to our sun, obviously our sun is the closest star to us, but the next closest star is Proxima Centauri, okay, and that is 4.3 light years away. Okay, so take that 9,460 billion and multiply it by 4.3, and that's how much you have. Okay, so it's really far. As a matter of fact, light that reaches us when we see it, it actually traveled almost 4.3 years ago. Okay, so when it started and until the time it got to us, it got 4.3 years. So if you think about it, we're almost time traveling. We are looking into the past. So if you imagine some other stars might be millions of light years away. That means the light that we see from that star is actually originated millions of years ago and took millions of years to get to our eyes. So that's pretty amazing. Now if we look, some stars appear brighter to us, right? Obviously our sun appears the brightest. Well, this is because some stars are closer to us than others. But those stars might not be the hottest or the biggest. So scientists use this term magnitude. Now magnitude, what does that mean? It's this definition. It's used to describe the brightness of a star. Now we have two types of magnitude. One, which we've talked about already, is the apparent magnitude, how it appears to our eyes, okay? So it's how bright it appears. And an example is our sun. Our sun has a really high apparent magnitude. It appears really bright to us. But is our sun the hottest or the biggest star in the sky? Not really. So scientists use terms as absolute magnitude, okay? And what absolute magnitude is, taking into consideration the distance. So if all of the stars were exactly the same distance from us, then we would be able to tell which one's brighter, okay? So if all the stars were at the same distance from us, that's its absolute magnitude. So how do we get absolute magnitude? We use the apparent magnitude, how it appears to us, as well as the distance. Those two things combined give us the absolute magnitude. So for example, our sun has an absolute magnitude of 4.8. So in terms of absolute magnitude, it's not that high. Others in the nighttime sky, including our solar system, including our universe, are 156,250 times that absolute magnitude. Okay, so there are some really bright stars out there, and our sun is just not one of them. So let's see how the brightness can relate to the temperature, okay, and the color. When we look out into the star, you might have noticed that there are different colors of stars. Well, this is because the color actually tells us about its surface temperature. So not the core of the star, but on the outside, what temperature it is. Now, we can think about color in terms of if you ever seen a iron being heated in a fire, okay, we're talking a really hot fire. Now, at first, when you put it into the fire, it's going to appear red, almost like it's glowing. And then you might see that it will turn yellow, and then white, which means it's really, really hot. And then, if you go even hotter, it's blue. Sometimes when you turn on an oven, gas oven, the flames will appear white and blue. That means it's really, really hot. So, it's the same with stars. As you go from red to yellow to white to blue, you go from cooler to hotter, okay? So, if we look at we have a chart here of different stars, and if a red star, which is the coolest, is going to be about 2,000 to 5,200 degrees Celsius. So it's really hot, but it's not the hottest out there. And an example of a red star is going to be Betelgeuse, okay? So the red star, not the hottest, and Betelgeuse is an example. Now a yellow star is going to be about 5,300 to 7,000 degrees Celsius. So we're getting hotter. So a yellow star is actually, an example is our sun. Our sun is a yellow star. That's why it appears yellow to us, and we always color it yellow. And then a white star is 7,200 to 9,500 degrees Celsius. And an example of a white star is the star Vega. And if we look at a blue star, the hottest, a blue star is going to be between 10,000 and 50,000 degrees Celsius. And an example is Bellatrix. If any Harry Potter fans are out there, Bellatrix Lestrange,